Alright, so today we're going to do percentage problems. So we start off with a simple question. What do we do? Okay, right, example 11, find 10% of 80. So all you have to do is just write down 10% times 80. And 10% of 80, which is just write 1/10 times 80. You can just cancel, which you get 8. Or you can use a calculator. So all you do is just press 10%. Remember, percentage is shift open bracket times by 80. Should give you the answer 8. Alright? You should have your calculator on your desk while this is happening so that you can check my working. Okay, have your calculator on your desk, please. Alright, once we've done that, we can then do the next problem. We now have to increase an amount by a percentage. So to increase that, there's two ways. The first way is just go 50 times 20%. That's the increase. Right? So you go 20% of 50, which is, just go 20, shift bracket times 50. So that gives you 10. So you go 10. And the new amount will be 10 plus 50. So you have to add 10 to the 50, which is 60. Okay? Now, this is one way to do it. A faster way will be, instead of finding 20%, we're going to find 120%. We're going to add 100% plus 20%, which gives you 120%. So what you do is, that 100 gives you the original amount. So we just do 50 multiplied by 120%. So you don't have to do two things. You just have to do one thing. So you go 50 times 120% gives you 60. I prefer this way because it's faster. Any question? Alright, I'm going to use the second way for the decrease. So you just go 100%. Subtract by 20% if it's decrease, so you're only getting 80%. So 80% of 60. So that's how you decrease 60 by 20% is to multiply the remaining 80%. So you go 80% like that times by 60 equal 48. So when it's decreased, obviously your answer will be smaller than 60. When it is increasing, your final answer will be bigger than your original answer. Any question? Right, percentage pretty easy. Increase, decrease, how to find percentage of a quantity? Yes? Good. Alright, let's do a more real life problem. Okay, example 13. I'm going to get a student to read. Nat, can you please read the example 13? Thank you. Yes, very good. So that's a real life problem. The cost of an iPad is this. It's already included 10% tax. We're going to calculate the original price. Okay, now this can be tricky. A very common thing students do is, oh, that includes 10%. Maybe just go decrease by 10%, just go 90%. That will be incorrect because it's not 90% of that. That will be wrong. We will see soon why this is the case. So what we do is, we have to use what we call the unitary method. So because that includes the 10% tax, the $792 is actually 110% of original, right? So if it's 110% of the original, we have to work out the 1% of original. Okay? So to get 1%, you just have to divide 792 by 110. But you don't have to do that yet. Just write down 1% is this. And on your final line of working, write 100%, which is the original. You times your answer by 100. So you just do that on a calculator. Let's see what it says. Drag it. Divide by 9 times by 10. No, you can't do 90%. Oh, hang on. Did you say divide by? Let me see. I'm not sure whether it gives you the same answer, but just write, let me just do this first, 720. So now explain what's the reason why you divide by 9. Is there any particular reason, or is this a trick you learned? Because the thing is that if the question is not 10%, it's something else, what would you do? Because it may be a trick you learned. But I don't know whether it works. Let's try. 792 divided by 9 and then times by 10. No, it doesn't give you. It gives you something bigger. Yeah. I think you are thinking that's without GST. Without the 10% tax. Yeah, just be careful. So this is the safest way to do. Yeah, yes. Or which is the same thing. Yeah, divide by 11 times by 10. Yeah. Because if you cancel this, the 0, yeah, it's like dividing by 11 times by 10. Yes, it is. All right, good. Any questions? So this is a very typical exam question. Make sure you use this method. If you do, now obviously if I just go 792 times by 90%, that's not going to be correct because you will get a different answer, right? Because if I'm going to increase this answer by 110%, you're not going to get the price of the iPad with the GST, with the 10%, right? It's different. However, if I do 720, include the 10% tax, you will get 792, so that's correct, okay? So we should write a conclusion, therefore, original price of iPad 2 is 720. Oh, good. Okay. Any questions? So that's the end of the percent. Oh, how come didn't forgot to press that one? Okay. That's just solve. Okay, good. All right. So that's the end of the percentage and fractions and everything. So today, what we're going to do on the next 3 pages, we're going to do indices. That involves a bit of algebra. Okay. So algebra. So you did learn about indices at the end of year 9 or maybe at the beginning of year 10 in the chapter 2 of your year 10 book. Hopefully you still remember. Okay, if not, that will be a revision for you. Let's start. Okay, just checking I'm still recording good. Okay, these are the basic indices law. So when in times with the same base, you add the indices, n plus n. If you divide, you subtract the indices. If there's a power, you raise it to another power, you multiply the indices. And anything to the power of 0 is 1. And when you have 2 numbers inside bracket with the same power, both of these numbers will get the same power. So it distributes. It distributes to the A and the B's. And the same thing for the fraction, both the numerator and the denominator are raised to the same power. Okay, so these are the index law. Make sure you write them down. Nat, did you write them down? Thank you. Okay, good. Let's continue. So we're going to do some examples to illustrate these rules. So not only need to memorize these rules, you have to learn how to apply them in questions. So we're going to do example 14. All right, some people are using a highlighter. That's excellent. Make sure you highlight important points. Let's do example 14. Say simplify this. So what you do is times means you plus, divide means subtract. You can do it in one step. So the question, the answer will be y to the power of 9 minus 3, which is 6. There. Yeah. Okay, now we'll move on to the next one. So the next one is using the third index law. Is it the third? No, not the fifth one, the distributed index. So both the 2 and the y to the power 5 gets the power 3. And we distribute the indices. And then we do the calculation. For 2 cubed, it's 8 because it's 2 times 2 times 2, 8. You can't do that on a calculator. So you can just press 2, that button, 3 gives you 8. And the other one, you need to multiply because that's an index law. 5 times 3. So the answer is 8 y to the power of 15. Make sure you show this working. Okay, you need to show working your test and your exam and of course your homework. Alright. All good. Let's do the next one. Next one is you distribute the power again, just more work. So you go 3 to the power 3, a squared cubed, 5 cubed, b cubed, c squared cubed. And then you simplify each. If it's a number, you have to work out what that is. So that will be 27, or you can check on a calculator. This one is 2 times 3 is 6. This is 125, b cubed, and then c to the power of 6 again. Yeah, okay, good. Done. And the next one we're going to do zero index. So be careful the difference. So the first one is 2 times 1. That zero index only affects the p. On the other hand, when there's a bracket, means everything becomes 1. See the difference between the second term and the first term? When there's no bracket in the first term, the 0 only applies to the p, but in the second one, the 0 applies everything, so it becomes 1. So the answer will be 2 plus 1 is 3. Any questions? So we illustrate these rules, but that's not all the index law. On the next page, you'll find more index law, which you have to work on. The first 4, these laws are a little bit easier, but the next one can be a bit harder. So you make sure you learn them. So all finished? Yep. Okay. Next page, you have what we call negative indices. These can be confusing because people can make mistakes and get confused with what it does. So when it's a negative index, it becomes a fraction. So you write 1 over a to the power of m. Right? So the negative index, take the a to the denominator with the 1 on the numerator, m. Right? And what if it's in the denominator? Obviously, that's the opposite. It becomes the numerator with a positive index. Okay, so note the difference between them. That one takes it down, the other one takes it up. If you have a fraction, it just becomes the reciprocal. Reciprocal means you swap the numerator and the denominator. And if you have an extra n, it's reciprocal first to power n. Once you reciprocal, the negative become positive. And once you reciprocal, you distribute the powers like we did before. So now we have these 4 things that you need to memorize. Okay, these 4. It looks quite straightforward now, but you need to be able to use them correctly in the examples that follow. So we'll do the first example, example 15. Okay, example 15. Write each of these as a positive indices. So using this rule, I could turn a negative index into a positive index. So that's what it does. So that's your negative becomes a positive. So we're going to use this rule to help us to do that. So for the first one, because it's a negative index, we just use the first rule. A to the power negative m becomes 1 over b to the power of 4. Right? I'm turning that into a positive index, but I'm going to write it as a fraction as a result of that. Right, what if it gets a little bit more complicated? Well, you just write 3, but this one becomes 1 over a to the power 4. Notice that I used a time symbol. Right? Use a time symbol to separate the 3 from the a's. And be very careful, only the a goes down, the 3 doesn't get dragged down because of the a. It stays on the top. And y squared stays on the top as well. Okay, now that's not your final answer. Your final answer needs to be a single term without the time symbol. So what you do is, if it's times, you just write over 1. means the denominator is 1. That will tell you to multiply the numerator together. And the numerator is 3, 1, and y squared. But the denominator is just a to the power of 4. So that means your answer will just be 3y squared over a to the power of 4. So you will see that the a to the power negative 4 just goes down. The other things that doesn't have a negative indices stays on the top of the fraction. Okay? Alright, okay, good. Let's look at the next one. What if you have a negative indices in the denominator? Well, I'm just going to use this rule, isn't it? I'm going to use this rule to simplify. But what if it has a 5? Well, the 5 doesn't cause much problem. You just have to write 5 multiplied by 1 over y to the power negative 3. Right? And that thing, now you look exactly like this rule here. It becomes a to the power positive m. So you write 5 times y cubed. So the final answer will be 5y cubed. It's very important that when you move things around, the 5 doesn't move. Or see, the 3 and the y squared doesn't move because it doesn't have a negative indices. Whatever the negative indices will cause that term to move up or down depending on the location. So if it's in the top, it goes at bottom. If it's at the bottom, it goes to the top. Okay? So be very careful. Alright. We're now going to do the next 4 problem. The next 4 problem is to ask you to write in index form. This is different from writing in positive indices. Alright, let's see what that means. For it to be index form, so this is a fraction, not in index form. It does have an index at the bottom, but not in index form. Index form is when you write it as a negative indices, when you have a fraction. So you have to write x to the power of negative 2. So that means what it's really saying doing reverse, going backwards. Before you go and write the negative indices as a fraction, now we'll go reverse. Okay? And the next problem, what if you have a 3 there? You do the same thing, 3 times 1 over x to the power 5. So only this becomes a negative indices. Yeah. Okay, good. Any questions? Alright, once we do that, we'll do the next one, C. Now this one, be very careful. 1 over 5x. I always split the numbers from the pronumeral. Okay, so split them like this, because the 1/5 stays as 1/5. Do not write that as a negative indices, but this will change to x to the power of negative 1. So don't change the 5, just the pronumeral. And the next one is, what if you have 2 terms? Well, you need a bracket and becomes negative 1. We're doing very good. We've got one more page to do before you start the exercise. So with the negative indices, with the positive indices, the last, yep, question? Yeah, I know, but when you say index form, they just want you to change the pronumeral. The number stays there. Yeah. All right. Let's move on to the next page. Fractional indices. So it gets confusing. You got the negative indices that turn into fraction, but you have a fractional indices, which means something very different. It means thirds. So it's very easy for students to get confused with the rules on this page, with the rules on the previous page. Make sure you look at them very carefully. They are very different. Okay, fractional indices. All right, let's do them now. Okay, fractional indices, square root of a is a to the power half. Okay, so very confusing. So if I got 1 over if I got say half, you can write that as 2 to the power negative 1. But 2 to the power or 3 to the power half means square root of 3. So people can get confused very easily. So make sure you see the differences between them. Okay? Alright, what if it's 1 over n means the nth root? Nth root. So notice that when it's a square root, we don't put a little 2 there, isn't it? We only put a number there if it's more than 2. So see, we don't put a little 2 there. We just say it's a square root. But anything more than square root, I need to have a number in front. Okay. All right. Next, we're going to do is cube root is 1/3. So nth root is 1 over n. And the last one, what if it's a full fraction? You just write a. The denominator will be. Oh, it doesn't write. Let me see that. So a, the denominator will be nth root, and the numerator will be the m there. Okay. So note where it is placed. All right, so we have these 4 rules. Make sure you look at them very carefully. And then we're going to apply them to the questions. All right, first one's pretty easy, square root of 49. Now your calculator is capable of handling fractional indices. So if you do 49 to the power of, 49 to the power of, no, 49 to the power of half, so you just write 1 over 2, it should give you 7. Just like you do square root of 49, gives you 7 as well. Okay, so you can do that on a calculator. But for the purpose of this exercise, I want you to practice writing them as a surd. These are called surd. Right, these are called surd. So that's on surd form. So the left one is called index form. So when you have a root sign, it's called a surd form. When it doesn't have a root sign, it's called the index form. And make sure you know how to change one form to the other. Okay, continuing on, we're going to do the next question. That will be using the last rule. This one here will be cube root of 8 to the power of 4. So you can just write that on a calculator. And then you go shift this. Now there's a cube root button. 8 to the power of 4, right? 16. Now if you want to know how to do it without a calculator, I suggest you do the cube root first, which is 2. And 2 to the power of 4 is 16. So you can also do it this way. All right, any questions? All right, next one. Be careful, there's a negative sign there. So we have to interpret what that means. The negative means 1 over 125 and turning into a positive index first. So the negative 1/3 becomes 1 over something with a positive indices, positive index. And then you do the cube root of that. So this exercise, even though you can do the whole thing with a calculator, but I want you to practice changing this index form to a surd form. Okay? And finally, you work this out, just get 1/5. Okay? Right, fractional indices. I think fractional one is the hardest one of all the other ones because it can be a bit confusing. So make sure you study them very carefully. And the last one, there's no fractional indices, so remember the negative reciprocal before you turn into a positive index. After reciprocal, you go 3 cubed over 2 cubed, like that. And then you get 27 over 8. We are almost there. So we've just done the first one. And then we got the next few. Yes. Okay, 18. Write in index form. Write in index form. So that means, so see before, we're writing in surd form to calculate. Next one is writing index form, going backwards. So So for this one, you just keep x to the power 5. So the square root means half. Half. And then using the index law you learned before, you multiply the 5 by the half. Right? You multiply them and leave it as a improper fraction. That's your final answer in index form. Index form means a term with a power. Okay? Alright, next one, what if it's a square root of something, you write just power half. Notice that I use a bracket. Whenever there's more than one term in there, I use a bracket. That's all you have to do. Okay. And then last one, need a bit more step. Okay, cube root, first things first, just write the cube root as a third. Right? And then inside, you got a square. Inside, you have a square. Alright. So you get 4x squared minus 1 inside. Let me just rub this. Inside there's a square, like that. And then you have to multiply the third by the 2, by the power 2. So you get 4x squared minus 1. Okay, 4x squared minus 1 squared times by third. Let me come out properly. Okay, good. So it does. So you get 2/3. Notice throughout the process, I still have a 1 in the numerator. So you keep it there for now, 2/3. But that's not in index form yet. Index form means no fraction. I mean, the index can be a fraction, but the expression can't be a fraction. So the 1 over something becomes a negative power. Negative power. That's your final answer. So notice that I take my time and show all the steps. If you show all the steps, you won't make a mistake, or it's unlikely you make a mistake. But if you just rush through, just go first step to the last step, you could write the wrong thing. So I'm just using one index law at a time, and it becomes simple, right? Cube root means a third times when it's at the bottom, switch on the top, but change the positive index into a negative index. Yes, Nat. Oh yeah, you can use this, just write 2/3 straight away. Yes, you can. Yeah, but I'm just thinking some people may forget this, so we'll just do it slowly. Yes, you can, yes. So you can just go from here to there straight away. Yes, yeah. Alright, let's do that. What's the next bit? Next bit, yeah. So the next one, we're going to use that rule. So 7/3, so you write like that, a plus b inside. The new denominator becomes the root, 7th root, and the numerator becomes cube. Notice I use a bracket because there's more than one term. Yeah. So that's without fractional indices, okay, which really means surf form. And we've got one more to do. Again, take your time. Start with the negative. The negative is 1 over with a positive index. Negative means 1 over. And then you need to have it without fractional indices. So you go 5th root r cubed using the last index law. Right, I've been talking for a while. How long have I been talking? Almost half an hour. So it's time for you to do some work. So please get out your page, which is the, now I remember doing this with you, which is the, not there. So get out your unit of work, so which you can write down what you have to do. Let me just do that. Okay. So